Welcome, everyone, to this latest DeSci Labs community call. Today, we're going to be talking about why Web3. So, explaining why it's important to have blockchain as a part of the scientific record. Just a couple of quick house cleaning items beforehand. We, I guess, big news. We just released a Twitter thread on function calls as citations and composable science. So for anyone who's interested in that, it's in the announcement where this community call was posted, and John is sharing his screen right now with that. So we'll be going through it in just a little bit. A couple other items. Chris just spoke, I believe, this weekend at CityDAO's conference on DeSci. So that will be posted to our YouTube in the coming future. There are quite a few conferences coming up. We will be presenting a demo at DeSci Boston on September 18th. We will be speaking at a panel at the ACM conference at MIT on September 19th. And then we will also be speaking at a DeSci panel at SmartCon on September 26th. There are a couple other conferences that are still in the works for that, but keep an eye out for all of these things as they happen. It's all exciting news. Thank you to everyone in the community who has submitted an article or tried to complete a bounty. Much appreciated. As always, we have an open call for anyone who would like to come and work with DeSci Labs as a developer. We are recruiting senior full stack devs to the team right now, so feel free to reach out if you're interested in that position. And we are also looking for people who are passionate about open science to come in and create stunning examples of what open science can be linked together permanently and immutably on chain. But with that, I think that's the majority of our updates for today's call. So, Chris, do you want to go ahead and take it away?
Sure. Thanks a lot for the update. So for us, it's been a big week. We've released a demonstration of fully reproducible science. One of a person I respect has put it this way. He said, reproducible, inline, in-browser, real-time, immutable, all linked and mapped together. And I think that really conveys the substance of what we've demonstrated here. Of course, we took two really. We were following that challenge. We did quite fast. So we had two stub papers, right, placeholders. We didn't take interesting statistic papers or things like that. So the next step for us will be to come up with actual high value use cases for these citations as function calls, and then more generally, high value demonstrations of how the UX of scientists can be dramatically improved using that system. And I think, I'm happy to dive more into this. I think one of the thing that is most important for me and for us as a community is building tools that improves the quality of the user experience of scientists. And one of our theories, and my theory in particular, which I think is actually really interesting and worth diving into, is that the fundamental thing we have to do is to upgrade the primary key of the scientific record. The primary key of the scientific record right now, for those of you who don't know, is the DOI, right? DOI.org. It has been created by the American Association of Publishers 30 years ago, during a time where scientific publications just started to become digital goods. And they needed a primary key in order to understand who owns what and who can sell what, right? So it was really a way for them to protect their copyright and to understand the extent of the turf of their competitors, essentially. There's a fascinating article on the DOI that you can find online. I'll link it later, that dives into the history. And there's fundamental problems with this primary key. Typically, imagine you have one paper as a researcher, you have one DOI. Then you post a new version. What happens? Well, do you get another DOI? Do you not? Different services will answer this problem in different ways. So on Zenodo, you have a master DOI, and then you have sub DOIs. Other services just say, no, it's one DOI and that's it. Others then will even upgrade the link to your initial DOI. So there's essentially a multiple problems. There's a problem of version control, which I just said. There's another problem, which is fragmentation, and fragmentation is the bigger problem. And what does that mean? That means you have a DOI for your paper, you have a DOI for your preprint, you have a DOI for your data, a DOI for your code, you have a video on YouTube, you have a slide deck on your lab website. So what does that mean? That means we have fragmented the landscape of all these artifacts. And to put them together, well, we rely on publishers. We rely on publishers to put on the article or to put on their webpage or on Crossref to say, hey, could you link these resources together so we have an idea that they belong together? And this is, again, it's not done in a standardized way. It's not done in a consistent way. And most of the time, most researchers don't even have DOIs for their code or their data. This is something which is considered best practice, but is far from universal. And at the end of the day, the reason for this is just a terrible user experience that it is. You have to sign up on 5 different services and get DOIs from these different services. And so this is very, very difficult. Oh, semi-crypto, you're a bit loud. Yeah, thanks. So this is very difficult for scientists to do. So now imagine, rather than having this space where you have this primary key, which is both fragmented and prevents version control, if we upgrade this and we say, hey, let's have a single primary key for each research object that allows us to address the entire linked data structure of a piece of research down to a single line of code. Just fully versionable, which has a step instantly, which returns both human and machine actionable data, which researchers can literally type in their IDE, in their Python environment, or whatever environment they're using, import paper, run paper, import data. Run that single PID because it allows an entire link and have a single identifier that allows anyone to address the entire linked data structure of your work. So this has a potential to be a tremendous advancement in terms of improving the workflows of scientists, and it has 2 very interesting consequences. One of them is we can automatically aggregate and detect these citations, these function calls as citations, and credit them to the original research object. So now all of a sudden, you have a single, your research object is gathering credit for the entirety of the linked data structure that comes with it, for your data, for your code, maybe for video, for methods, for all of these objects. They're gathering credit into a place that aggregates it automatically because everything is immutable and on-chain. That means anyone can verify that these objects have indeed been reutilized. So that can be a big game changer. And also in terms of user experience, we don't need citations aggregators. We don't need things like reference managers anymore. It just happens. You upload your DeSci node, you create your research object, and we're crediting all of the other research objects that have been composed upon without any reference manager. And of course, there's one problem with all of this, right? It's a big problem. It's like, imagine if there was a platform that was storing the entirety of the scientific record, like a Web2 platform, like a Facebook of science, right? Where we put all our artifacts and the entirety of human knowledge. We're having it all on this platform. Now, who would want that, right? Who would essentially tolerate the level of power and monopoly that it could create for that platform, right? Imagine that platform could start erecting paywalls. It could start shutting off APIs. Could be like, oh, whatever. Oh yeah, you knew this was free in the past. Yeah, we allow developers to build on our APIs. Yeah, of course. But we've had a change of policy. This has happened in the past many times with Twitter, with Facebook, with all of these Web 2 giants that started with these permissive APIs before cutting them off, right? To protect their turf and to essentially increase their competitive edge and their monopolies over this data. So that's a big problem. And this is where this idea of open state comes in. So what is open state? So we talk about open state a lot. The idea of open state, so Balaji was putting it this way, open state is the next open source. The idea of open source is you have the full code's available. Anyone can deploy your code. Anyone can work on your code, can fork it, can make amendments to it, file PRs, etc. Right? So it's the idea of composable code. Now, open state is essentially the idea of a program that runs that has all of its states in a way that cannot be censored. So, for example, a social graph of Facebook would be in an API that cannot be shut off. You'd have all of these information that's held in these Web 2 silos with built-in guarantees that nobody can be cut off from listening, from gathering data, from accessing the content, essentially. So that's open state. And so how does that work? Well, blockchains have this interesting property of being essentially multiplayer databases. That means we can essentially index information on a blockchain, and anyone can read that information because the reads are free and there's unanimous agreement on the content of the underlying states. And so we can essentially pull this information. Anyone who's listening to the events of this open index can retrieve the entire linked data structure of that research object from Content Address Storage Protocol, in this case IPFS, right? So that's open state. That means that no APIs can be shut off. That means that no paywalls can ever be erected again. And finally, that means that scientists are in control of the primary key of the scientific record. Because the PID, the persistent identifier, for linked data that we're creating is fully under the control of the people that create the research object using essentially public-private key infrastructure. So what does that do? That essentially makes it first of all, it makes it liberating, right? So it's something that empowers, returns independence and returns control to scientists for their research. And it solves for many different types of issues. It solves for the fears of consolidation of power. So in the future, the way we envision this DeSci infrastructure is an open state stack where everyone can deploy their own DeSci gateway, right? And what's a gateway? Well, a gateway is the opposite of a silo. A gateway is essentially a place where people can create research objects, commit them to this open state repository, and query the open state repository to give access to others to these research objects, right? So that's the concept of a gateway. And there shouldn't be only one gateway. There should be a plurality of gateway. Every community in the DeSci space and more should be able to deploy their own gateways and make it their own and customize it to their own need and own it. It's their spot. And the only thing that essentially rallies this entire network together is this idea of creating open state access to knowledge and fostering composable science and providing an escape hatch to scientists so that they can be in control again of the scientific record. So that's the idea here. Yeah, I mean, we're super excited about all of this. This is a major milestone for us. I can go on a long monologue, but I'd love to make this interactive. So, just go out, shoot questions, and let's make this a conversation.
But your monologues are so fun. Anyone who has a question, you're welcome to throw it in the chat. You're welcome to unmute yourself as well. Get in here and ask Chris or Sina any questions you got. To kick us off, I'm very interested about, where was it? It had to do with, there it is, the chunk about the fair data. So I'm wondering how all this connects to essentially this sort of mini thread in this
Oh yeah,
larger
yeah.
thread related, like connecting the current system and funders and the current attempts to do stuff like that. Like
Yeah,
what
so
you said.
what we call in DeSci composable science, funders call the fair data principles, right? Let's be honest about that. That is exactly this idea behind the fair data principles is to make science more composable. Making every component of a scientific discovery findable, accessible, interoperable, and reusable. The idea is that if we accompany every resource, every research output, and we essentially make them abide to these four properties, we can dramatically accelerate reuse of scientific resources, right, and research outputs. And this has been a global push. It's especially influential in Europe, but also in the States, where funders in Europe, for example, European Science Cloud, but not only, there's many, many funder organizations that are insisting now, well, research outputs should conform to the fair data principles. So it's essentially a powerful rallying call that, we talked about the fair data principles, I think, 2 community calls back. I'll enjoin you to listen to this one again. But it's essentially a global push towards more composable science. Now, why is it different in DeSci, right? What makes DeSci more fair than fair? Well, the fair data principles are agnostic about things like persistent identifier. They say, well, every resource needs a persistent identifier. It can be ARC, it can be DOI, it can be any of these other unique keys, right? Well, what we do that is different is that we say, hey, we're proposing a new model, or at least we're proposing a proof of concept for a new model of a new primary key for the scientific record, which allows addressing the entire linked data structure of a piece of published research, right? So our unit of knowledge, and this goes back to this idea of unit of knowledge, is no longer the solitary PDF. The unit of publication becomes a graph of knowledge, right? It becomes not only the PDF, but also your data, also your code, also all these other components, which all are essentially under a single primary key for linked data object. And you saw in the video, you saw when Sina is essentially describing our preliminary schema here, he says, well, within that persistent identifier, you can select the version, you can select the component, you can select the file, you can essentially select any arbitrary piece of that linked data structure with a single namespace, right? Another way to think about it is that every scientific discovery becomes, a standardized website, right? So it allows you to address subpages and subcomponents and places like that, right? So it allows us to to facilitate, essentially that's really the word, to facilitate fair, right, at scale, because we're improving the lives of scientists by making their user experience much better, which I think is really fundamental. And by doing their experience much better, by giving them a much better user experience, the consequence of that is that not only can they create these linked data structures, but other colleagues, other scientists can import any resource with a single PID anywhere in their IDE, in their browser. All of this works from a single persistent identifier, right? So that's where we're going a step. We're essentially innovating on this notion of facilitating the fair data principles. That's really what we're trying to do here.
Yeah, instead of asking people to use the fair principles, you're building kind of the technology that almost forces it.
Yeah, we're trying to make it simple, right? That's the key.
Yeah.
We're trying to dumb it down, to make it as simple as possible for a scientist to produce a fair research object. And, to take this above, you can imagine my ideal product as a scientist. I want to drag and drop my PDF. I want to copy paste my GitHub link. I want to drag and drop my data files, or I want to mark them with my repo. I want to copy paste my YouTube link. and maybe want to, copy paste a blog post or a slide deck I made. I want to do that. And then I want to get a persistent identifier that allows me to address any one of these pieces, right? The entire linked data structure of all of that, right? Simply and easily. That's fundamental. And that can really go a long way in facilitating the adoptions of the fair data principles.
And I'm sure you also want to accumulate credit across all these resources you linked.
Oh yeah, and more important. Okay, this is another thing, right? There's a problem about citation fragmentation, right? So in many cases, you don't want your data to be cited. You'd prefer for your publication to be cited. Why? Because the way the H-index is calculated. So there's a lot of perverse incentives that make it so that scientists do not want citations to be fragmented across multiple objects. We want to have citations accrue to a single object, which is, in the way we think about it, simply is the paper, right? That is the object. It's the published paper or the preprint. That is the object that matters, right? So now, what happens if I allow automatic accrual of credit to any of the linked components of my research object? All of that credit is accrued to the research object, right? To, the paper, essentially. And that has huge benefits in terms of preventing citation fragmentation, right? So that's very important. And we can do this without even having reference managers and any of it, right? So this is the other thing. I personally, and I know it's not the case for everyone, but I never liked working with reference lists. I would always get, I'd be like, oh, Mendeley, what is this thing you've just inserted? There's a bunch of mistakes, the DOIs half of them are broken. The reason why we still write out the entire title, names of the authors, page where it's been published, the name of the journal on top of the DOI, well, is that we just don't trust DOIs. But if we had permalinks that wouldn't break, we wouldn't need to add all of this accessory information, right? If we didn't have Google Scholar robots that would find a reference list and essentially use fuzzy search to connect references to papers, we wouldn't need that format, right? Essentially, it would just become ceremonial. Now imagine a system that allows you to just have hyperlinks, right? You just creating hyperlinks, while at the same time making sure every one of these hyperlinks is both permanent, right? Unbreakable, and second, that it automatically accrues credit to the target research object, right? What a quality of life improvement this would be. Now, I don't think we're going to get there, at least not very soon, because the system as it's set up puts a high value on these reference lists, right? It's part of something being science, something to feel scientific, and to needs to have, a reference list, need to have these types of let's say, in the future, they could be ceremonial objects, essentially. Today, they serve a vital function, but in the future, they could become ceremonial. I still think they'll be done, but we can radically improve the experience of doing that. And what did we have else in that tweet?
There's so much. There's so much there. Something that you said during the normal, the sort of intro monologue there, also piqued my interest. I was having a conversation with someone from DeSci World the other day, and they are a researcher. I think they're a PhD candidate or getting their master's or something like that. And they didn't know, once they graduated, what of their research would be their own and what of it would be owned by the institution which they're a part of. And during the intro, you mentioned something about a researcher owning their own work or owning their own research object or something like that.
Yeah.
I mishear that?
Okay, so this is the question of ownership is very complex, right? So there's multiple things that are owned by multiple parties. It's not clear who owns the data. It's probably the funder in the institution, perhaps the scientist. It's not clear. I think there's a lot of unclarity here, and I'm not an expert. I don't know who owns the data, but I'm pretty sure that it's not the scientist. Same with the IP, right? You have IP transfer offices. Any work performed at the university, the IP belongs de facto to the university, I believe, except in some cases, and then you have to have a negotiation with the IP transfer office. Essentially, there's a lot of complexity surrounding IP and ownership. When I speak of ownership, I talk about the publication ownership, right? So I talk about essentially ownership of the primary key. You know how, people can get an ENS domain and own their ENS domain? It's very similar. You can own your PID, you can own your persistent identifier. That means you can make updates to it. You can change it. You can produce. You can't change the PID, but you can create new versions, right? You can version the components while still keeping that immutable trace of version history, right? So that's what I mean by that. It's essentially the researcher can control the primary key of their research object. But that's an important form of ownership. It's important because it's important on different levels. It's important because it essentially is disintermediating. It's disintermediating certain entities that have been extracting for a long time all sorts of monopolistic like behaviors and on the labor of scientists. It's important because it returns control, a sense of control, without and it also assuages the fears of DeSci becoming a giant centralized platform, right? Like a new Elsevier 2.0. It's like, well, no, like you have full control over your PIDs, and by the way, anyone can spin off a gateway, and nobody can shut down the APIs, and no one can stop others from reading the content of this open state repository. And these are guarantees that are built in by the technology.
I think that's a huge point. Go ahead, Ellie.
Yeah, a question I had relating to all of this is it feels like we've been talking a lot about the UX and how we make this simpler for people to do, which I think, as you said, is super important. But I'm wondering, there's kind of this other argument about upstream or downstream filtering where you're like, hey, but how do you make sure that the simple still gets done? Because there will always be some amount of friction in making even just writing good code that is executable by enough people or readable or all these things. So I'm wondering, are there incentives in the platform? Are you how are you thinking about the idea of how do you make sure that we actually adhere to the FAIR principles even if we're decreasing the friction?
So the FAIR principle, essentially, we want to automate everything, right? That's the end game. The end game is total automation so that any piece of uploaded content, arbitrary streams of bytes, would become verified by the platform. Now we're not there yet, of course. So there are things like ontologies, controlled vocabularies, the so-called point 1.3 of the R letter. And 1.3 is that the data is accompanied by descriptors that are accepted by communities, something along those lines, right? That's a very difficult one to verify and to abide to. So there's some difficult points to crack that remain with the FAIR data principles, but we're already quite confident we've cracked a big one with our proof of concept around the persistent identifiers. Right? That's a persistent identifiers play an incredibly important roles in the FAIR data principle, and it hasn't been clear so far how to improve the UX and improve the utility of these persistent identifiers. And what we've done here with our demonstration of composable science is we've demonstrated increased utility, accelerated utility from persistent identifiers. There's some other nuts to crack. One of them is the metadata descriptors, right? And so we have ideas about that, and we're actually super excited to show you and to demonstrate these ideas about automated ontology classification. We're going to be doing that during our demo day. And I just don't want to spoil it for you guys yet, so that'll be the topic of a next community call. But yeah, I mean, in essence, for us, it's going to be paramount to make the lives of scientists as simple as possible.
I think also touching on the point that Ellie brought up about, how do we, have the code structure a certain way so it can be runnable and that sort of stuff. So I don't know if you took a look at kind of the current commit flow, but we have this left-hand commit pane that comes up and kind of gives you a few prompts and kind of warnings and surfaces some issues, right? So right now it's like, hey, you're missing your metadata, or you need to connect your ability to digitally sign this object, right? But I could see a future where we do some stuff like static code analysis. and basically say, hey, it looks like you're uploading Python project. Did you make sure to include a requirements file, right? These sorts of things. And then, for stuff that has an API component, for example, we could be like, there's a requirement here that you should have a Docker file. Would you like to add one? That sort of stuff. So I could see that playing a role in terms of improving user experience to create reproducible science.
Yeah, that's a very good point, a very concrete point. Yeah, we've been thinking a lot about how to take people by the hand in the commit flow, and I think you can see it in the video. So this is just a start, right? This is us essentially showing how we can have a sequential to-do list of actions and having some smart logic implemented such that through a sequential experience of just clicking one after another and fixing each of these points, you get to the finish line, right? And it gives clear signals to the scientist what remains to be done to the user, right? And so this is something which I mean is very fundamental. And as Sina said, we can enrich this, right? So this is an area where we can keep enriching essentially the guardrails to ensure that the research object conforms to the type of expectations of the system, right? While keeping the cognitive load, and I think this is a really important term, is the cognitive load of the user as low as possible, right? So essentially by guiding them by the hand and saying, hey, now that you've done this, now that you've pulled all your components into one place, now that you're about to become, become this scientific creator and creating this DeSci node, there's still these points you need to address, and here's the order to do it, and here's what you have to do.
Okay, that's super helpful. And then, just to repeat a little bit, one chunk that you mentioned really briefly was based off of community. So you said some of these requirements could be altered, adjusted, reinforced. Potentially, you create a new almost to-do list for someone within your community based off of your agreed upon, what you think is important based off of your field or things like this.
Yeah, so this is very specific. This is R1.3 of the FAIR data principles, and it's about metadata descriptors and controlled vocabularies and ontologies. And it's a bag of worm, to be honest. It's one of those requirements which leads to decision by committees and more committees and more committees, doing more releases of guidelines and workshops and these things, right? It's
But wait, Ellie, were you talking about our communities able to customize that left-hand pane? Is that what you're getting at?
I mean, that was, I think, that was the specific, maybe action you could do. But then I think I am more interested in this kind of R1.3 that he's talking about and what it means and how you would integrate that into the structure.
So R1.3 is very difficult. It's very difficult. We think we have an idea on how to solve it. And it involves the general index. So yeah, we're bullish on that. We're not, we're looking forward to the next chapter where we can really facilitate the implementation of R1.3 using the general index.
Is it open enough to dig into a little bit of how you're thinking of the general index, or is that still in the future?
Yeah, I mean, I'm happy to talk about it. It's just, it's I want to keep also the future community calls interesting, but yeah, I'll talk about it next time. I'll talk about it.
I don't think you can be boring, Chris. I don't think you need to worry about it. Sina, although since you brought it up, I am curious now. Can communities change that left-hand panel, or does this have to do with gateways and how they manage themselves, or what were you talking about there?
Correct. Yeah. So correct. So basically, a gateway would be effectively you could think of what's currently on nodes.desci.com as our prototype gateway, and it kind of has a configuration that we've defined. However, we've put this together in a way that any community can take the exact same, different resources, these different server resources and blockchain resources, and deploy them themselves, self-hosted or on the cloud. And that would also involve configuration. So they would be able to, have different configurations, different standards, for what actually gets published through that particular gateway. And we think that that's going to be very useful for specific academic institutions, whether it's universities or government agencies and so on.
That's
or,
so
or
cool.
just or their own communities, like kind of grassroots kind of communities. So
Yeah, I think that's a huge point. And Chris, I think you talked about this in passing a little bit earlier. The idea that this technology is the technology that can be used by everyone, and it's really just opening the field to more people to be able to play. So like these big institutions, Harvard or Oxford or like the NIH or whatever, they can run their own gateways that set their own standards and hand out their own badges, which we didn't even talk about, and control a user flow. And at the same time, these grassroots organizations that you just brought up can do the exact same thing. And if the grassroots organization is good enough at what they do, you know what? Maybe they can get to the same level as NIH. Unlikely, but it's like the opportunity exists for them to participate and for them to compete in sort of this arena of scientific publication and creation, knowledge creation. It's super exciting.
Yeah, absolutely. And I think it's a big departure from the Web 2 model of, hey, let's make a giant database that's proprietary, which create huge network effects, and close off the APIs, right? And monetize it. So this is the Web 2 model, and we can do a radically different vision with an open state repository, which is powered by a network of independent and sovereign gateways. And these gateways might be institutional players, right? They might be, let's say, grassroots communities deploying their own gateways. They could be all sorts of use case for these gateways, right? You can have research organizations like protocol labs. You could have university libraries. You could have, research groups, small research groups that are tackling a specific problem. You can think of all sorts of entities that would be interested in spinning off a gateway to provide resources to their affiliated researchers, right? Because gateways do two things in addition to doing the read and write. Well, they also provide storage and compute, right? And so you can imagine gateways that compete, to provide the best storage and compute to their communities. There's going to be communities that are going to need a ton of compute, right? Think of AI community, right? Co-located compute, GPUs, those types of very expensive and very competitive resources, right? You're going to have other communities that have no need at all for any compute whatsoever, right? Think of humanities, think of, a gateway about, archaeology or something like that, right? Or people that essentially mathematicians that don't do, let's say, large scale simulations and compute driven proofs, right? So you can imagine communities that have no need to provide compute. So there's going to be this ideal is to make them configurable and customizable so that communities can really customize them to the needs and desires of their constituents. So that those are the gateways.
So if I publish through one of the gateways, can the other gateways also access that? Or do I even publish through a gateway? Am I using the right language there?
Yeah, exactly. You publish through a gateway. You can think of a gateway, concretely, it's a website, right? Feels like a website. It's like website access, post, publish, create, DeSci node. Now, whether or not every gateway surfaces your work is a completely other question, right? Well, every gateway has the potential to do so. They can go on the JRingo node that you created. They might have completely different curation algorithms, right? They might not all surface your node. It might be completely irrelevant for a certain community to surface that information, right? So there's you can, and same with moderation, right? Some gateways might have certain terms and conditions. Other gateways might have certain preferences for things that are acceptable, not acceptable, and these are things that are essentially moderation is handled at the gateway level, right? So while we would, while there would be like a global state list that would be shared between gateways would be responsible for whitelisting their constituents, moderating their platform, and all of that, right? And this, I think, is very important because we've seen that moderation is a very complicated topic, especially if you do it in a centralized organization. Right? We've seen this with Facebook, Twitter, these things, right? We want to essentially distributed moderation, decentralized moderation which creates a much stronger sense of it's not only because it's simpler to do, right? Technically, it requires less manpower. This manpower is more distributed. It's also because when you're publishing or you're creating research objects as part of a smaller community, I think you feel a much larger sense of responsibility, right? And responsibility could translate into higher quality content, less need to moderation, a higher degree of quality control at the end of the day.
Definitely. Each gateway is going to have a different priority and left and right. And for anyone who's maybe curious about exploring what a gateway is a little further, this is something that exists in the crypto space already. It's on the library blockchain, which is actually very similar to what is being built here at DeSci Labs, but for a different purpose. But we have different portals that surface different video content from the underlying data infrastructure, and they choose which way to view it to their users. And then the user goes to one of these portals to upload content that they're allowed to upload through that. It's such an interesting potential that this technology enables. And I think, man, we should have a whole call on gateways too, because there's a lot to go through with. But let's bring.
To be clear, it's still an area where we're of heavy conceptualization. One of the clearest use case for these things is there's a big trend right now. It's funder-led publishing, right? Funders want to control the publishing infrastructure. You see that with big publishers, big funders like the Wellcome Trust. They're making deals with F1000 to be their publishing gateway. So funder-led publishing is also something which is an emerging trend right now in the world. And this trend is going to keep consolidating as we have now had the OSTP memo that has essentially mandated public access to data and papers by 2026. We're going to have a big push. There's going to be essentially an increase in author publishing cost. Gold OA is going to overtake, and that's going to lead to backlashes. There's going to be friction with funders. There's going to be friction with scientists. There's going to be greater and greater part of the research budgets and research grants that go towards paying these author publishing costs. And it's very likely that funders will continue on this trend of funder-led publishing, right? And there's of course issues with this, but one of the things that funders really want is they want ways to essentially be crediting the reuse of research artifact, right? They want to be able to reward scientists that go the extra mile to make reusable and composable science. And that has been a primary goal of the European Science Cloud, which is a giga project led by the European Union to create interoperable research objects, hundreds of millions of euros, going to giant tenders and big companies that are building out this infrastructure. And it's essentially, it's the funders, and as we say in the tweets, right, it's not for lack of will that the incentives for sharing data are bad. It's for lack of sight. Because companies like Clarivate and Elsevier sell funder at a very high premium the ability to track their impact. And these companies perniciously have very little interest in tracking impacts of reused artifacts because they don't have the infrastructures to store these artifacts in the first place. What they have the infrastructure for is for PDFs and counting citations, right? So that's what they sell to funders. They're like, oh, you want to see your impact? Well, here, you invested $2.8 billion in Alzheimer research. Well, you've got 10,000 PDFs with that many citations out of your money, right? That's what they're being sold. And that's wrong. That's essentially, keeping our funders with blinders on. What we want to surface and what is going to be essential to surface is the entirety of the reused artifacts so that funders can reward scientists, right? Reward scientists for creating these interoperable research objects that others build upon. The shoulder of giant of the past has been standing on giant PDFs. The shoulder of giants of the future is going to be standing on artifacts such as code, such as data, such as all these other components of research that others will build upon and credit the original collector, the original author, the original coder. So that's what we're fighting for.
That sounds great. Guys, we got 10 minutes left if anyone wants to get questions into Chris or Sina about this latest release. And I do love how it's put in the first comment, first tweet. Reproducible science, citations as function calls, and reclaiming the scientific record. I am curious though, if you're allowed to cite anything in a paper or annotate it, you basically highlight it and cite it, it seems. What's to keep someone from just citing the word "the" like 1,000 times just to pump up their score of citation, sort of?
There's always gonna, when there's a metric, there's always gonna be people to game it. It's inevitable. And yeah, you raise a very, very good point. And I think this is why we're also going to be designing these systems with the DeSci Foundation and many other great scientists and meta scientists that are going to be helping us, and economists as well that are helping us right now think of the adverse incentives or pitfalls that we need to account for. You could imagine.
I think step one is like you allow people to do fine-grained citations easily, and then from there, with all the information, you can filter out the noise, right? So we're able, if we see that stuff is being used maliciously to inflate credit, there's ways that we can filter that out.
And I think the other thing is since everything is immutable, it actually does, there's something about, hey, I'm going to game citations on this paper and put up a piece of code that is reusing my previously published artifacts with like 10,000 citations as function calls, right? And you just go on this Python code file and there's like, a million reuse and like you're inflating your ratings, right? It's a problem, of course. But because the data is immutable, it kind of makes you look like a clown, right? It's like, come on, this is this is you're taking here the example of the self-citation, right? A self-citation problem or not problem, depending how you see it. And you could say, well, that problem of self-citation will apply to citations as function calls, and you want to have guardrails around this. And the answer is yes, absolutely, you do. And one of the biggest guardrail you can have around it is total transparency and immutability of the data that has been published. Because if you add total transparency and immutability plus the property of open verifiability, which we've talked about previously, then you really have very strong incentives against that kind of abuse.
And there's certainly principles within graph theory that we can apply, for example, to surface collusion rings of folks that cite each other to boost their rankings, right? So like Chris is saying, because it's open, transparent, immutable, we can create tools to, run some graph algorithms on the network and surface up collusion rings, and it wouldn't be too difficult to do something like that.
Yeah, that's a very interesting perspective on it. I don't know how much power actually transparency and immutability is, because you can see it in the space that with these with the projects that already have these aspects, these characteristics, and they get fuzzed all the time. And it's an attack vector. So if I don't like a researcher, I go, if it looks bad, if they get cited the word "the" 1,000 times, I can go and do that to their paper. So I'm interested for the future with what you were talking about with the incentives and how complex these different incentive mechanisms can end up being, that sort of nudge people to do the right thing and maybe punish people for doing the wrong thing, but that in itself is a whole nother story. Punitive systems might not work very well.
Yeah, I'm very careful about introducing any form of explicit incentives or punishment in any of these systems. One of them, I think, the behavior of citing a scientist is something that a scientist himself should not be able to control, right? That the author of the work should not be able to control whether or not he gets cited or not. Of course, there's all sorts of informal networks and ways where you can increase the influence of your work, etc. But at the end, it's the least, let's say, the least corrupted measure we have of having made an impact within a scientific discipline, or having so it is a there's ways to game it. It's imperfect. The problems of citations today are very likely going to apply, so that the type of ways they can be gamed are also going to be able, in certain ways, to be applied to these citations as function calls, right? There's no way around it. But like Sina was saying, there's going to be, because it's an open state system, anyone's going to be able to, sprawl out a pet project, that just goes read this data, uses, graph indexing, and essentially says, hey, guys, is this normal? Why is there like a function that returns that's been cited, 10 times by Jay Ringo, right, from his previous paper,
And there's similar techniques that are used to filter out, for example, wash trading.
Yep.
You could, similar sorts of techniques are used for that. And also when you're analyzing social media activity, and you have like rings of bots kind of like pumping each other's content up. These sorts of things you can surface, and there's actually a decent amount of research that's been done on this stuff. So similar things could be applied to prevent this sort of gaming, or
Yeah,
at least
I
surface
agree.
it.
The papers I've read tend to say it's not very effective, but there's more and more methods. And what I'm hearing is, it sounds like maybe this might be sort of a gated layer on top of the gateway, so to speak, proprietary. Thank you. So someone might develop the methods to find this false citation. So they might find a method to produce good credit, to say like, this is good credit, this paper is cited genuinely, and then people will go to that gateway because they have a method for doing these things properly, and they have a good reputation around what they surface and how they score the papers that are shown through that gateway. That might be interesting.
Yeah. And I think that's the thing that's interesting about composability, is like, it's not just the science that's composable, it's the whole DeSci stack that's composable. And that's what we want to do. We want people from every community to just spin off their own layers, and just to be building off of the blocks that they decide to use, and create their own tools to interact with those blocks. Because we have to be, this is a quest of a tremendous impact and importance, and we're going to need to throw as many things as we can on the wall and see what sticks at the end, right? So this is why we have to think about that stack as composable and buildable building blocks.
Yeah, and I guess in the same vein, as we wrap up here, at the end of the thread, y'all mentioned open sourcing in winter. So I don't know, maybe talk about that a little bit. What do you think people are going to do with the repo once it's out there and people can experiment with all the software that you guys been developing?
I'm really excited about it. So I it's one of those things. I'm praying and hoping that we can trigger a open source community developer movement, because the mission is so important, right? Reclaiming the scientific record, breaking the grasp of these exploitative monopolies, improving reproducibility. All of these are causes that are beyond that transcends each of us, and it's the type of cause that could attract high quality open source community. And we just have to get the momentum going, and we're gonna do it this winter. And let's see what it does. We're gonna need some great early open source contributors and stewards to take this to the next level, because clearly it's a project that is bigger than all of us. And we want to be able to let everyone compose on it and build, the future of what science could be.
Bigger than everyone but Sina, who put this thing together.
Yeah, exactly. Except Sina. So yes, for those of you who don't know, Sina has put this citations as function call together in a tremendous sprint, where he has played a guitar solo of programming genius along this journey, and we are all tremendously grateful and in awe of what he has delivered so far. So thanks, you, Sina.
It's absolutely crazy to watch.
Very generous. Thank you.
All right, guys. I'm out of questions, which is rare, but it happens sometimes. So But I guess it's all right because we're at the hour. Does anyone have any questions they want to squeeze in here, Chris and Sina, regarding the Balaji challenge and kind of the completion of that challenge? If not, Eric, do you have anything you want to add at the end here?
No, I think this was an amazing call, and thank you, Chris and Sina. You're a rock star.
Thank you, everyone.
Awesome.
See you for the
Thanks,
next
everyone.
call.
Yeah, we'll be back. We're
Mhm.
sticking around for an hour. Just kind of hang out. We can talk more about the thread. We can talk about anything else we didn't get to. Otherwise, we'll be back next week at noon. Hope to see everyone then.